Alrighty, this is the review for your circle test. The test is only covering section 10.1 through 10.5. So everything we've taken notes on, so no need to worry that we haven't completed the packet because we're only testing up to that point where we stopped. Alrighty. For number 13, it says name a diameter on circles O. Also, please make sure you show all your work for the review on a separate paper because you're going to turn it in separately from the other side's homework assignment. So again, make sure you do all your work for the review on separate paper. It's even in bold at the top of this side of the sheet. Thank you. So number 13, name a diameter. The role of the diameter is to go from one part of the circle to the other part, but it also has to go through the center. So the only line that I see doing that on this circle is line FG. So that is our diameter. So when we write the name of the diameter, you would put FG or GF, and you put the segment bar on top. Segment bar, please don't forget the segment bar. It now wants us to name two chords. The role of a chord is to go from edge to edge of the circle. So I see that AB is doing that, as well as FG again. FG is a chord. Yes, a diameter is a chord. So again, that's segment AB and FG. And now it wants us to name a tangent. The role of a tangent is to be a line not inside the circle. It's coming from outside and it's only allowed to touch the circle at one location. So that means it would be CE. CE is our tangent. And since it's continuing on, you could put line CE like that, or you could do segment CE with the segment bar. Either one would be fine. For number 16, says the wheels on Elliot's truck each have a circumference of 22 inches. Determine the radius of each wheel. So when we talked about circumference, we talked about two different formulas. The circumference formula is 2 times pi times radius, or it's diameter times pi. But since we're looking for the radius, it's probably best that we use 2 times pi times radius. So they give us the circumference, 22. So in our formula where we see C, we're going to replace it with 22. So we're going to put 22 is equal to 2 times pi times radius. And notice I emphasize the word times. So we are multiplying the 2 with the pi with the radius. So if I want radius to be isolated and left alone, I would have to divide by 2 and by pi. And you can do those at the same time. Divide by 2 and pi at the same time to remove it from the right side of the equation. And it's now on the left side. So I need to take 22 divided by 2 pi to get my radius. So R is going to equal, handy dandy calculator. And when you use the calculator, use the pi button. So 22 divided by, notice I put it in parentheses, 2 and pi is second caret top. If you don't put it in parentheses, you're not going to get the right answer. So it's about 3.5. If you want to be on the safe side, if you forget to put it in parentheses, you can do alpha y equals 1 to get your fraction. And then if you use the fraction, you don't have to worry about parentheses. Because I know if you forget that, you're going to not get the right answer. So you might as well just use the fraction to begin with. So again, your radius is approximately 3.15. I'm 3.5, sorry, inches. Number 17 tells us in circle A, the measure of angle CAE. If I trace it, CAE, so it's that angle there, is 125 degrees. Degrees. It wants us to fill in the blank. And then tell if each arc is a minor arc, a major arc, or a semicircle. So the first arc we're looking for is arc DE. Arc DE is this arc here. I know that if I combine the angle that I'm given with angle DAE, I know that's a linear pair. And in other words, they should add up to equal 180. So if I take 180 and subtract 125, I would get 55. So this angle DAE is 55. So since angle DAE is 55, the measure of arc DE will equal the measure of angle DAE. So that means it'll equal 55 degrees as well. And since that is less than 180, that makes it a minor arc. Now it wants us to talk about arc EDC. So start at E, travel around to D, all the way around to C. So if you notice, I nearly covered the entire circle with the exception of that one slice, the 125 slice. So an entire circle measures 360 degrees. So I could take 360 minus that slice of 125, and I would get the entire measure of arc EDC. So that's 5, and that is 3, and that's a 1, or 2, sorry. Yes. So it's 235 degrees. Which classifies it as a major arc because it is more than 180 degrees. And now the last arc I'm going to find is arc CED. Start at C, go to E, and then to D. So I already told you that these two angles were a linear pair, making them 180. So that means the measure of arc CED is 180. Which makes it a semicircle. Another way to look at it is the line segment C to D is a diameter splitting the circle in half. So half of 360 is 180. That's another way of looking at it. You have options. Just go with the right one. Number 18 wants us to draw a circle P. So that points X and Y lie on the circle. So let's draw us a circle. There we go. And it wants X and Y on the circle. So there's X, there's Y. And then it said, oh, sorry, P is in the middle. Sorry, forgot about that. It's your center. Good. It says the measure of angle XPY. So let's draw this angle. From X to P and from P to Y. All right. It's 90 degrees. Obviously, my illustration is not drawn to scale, but this angle is 90 degrees. It also informs us that P to X is 5 meters. It wants us to find the length of arc XY. So we're finding the length of this arc right here. Yes, the highlighter tool is not working right. But anywho, to find the length of an arc, and again, we cannot stress that enough, length of an arc has a formula, and the formula is L is equal to the measure of the arc divided by 360 times 2 pi radius. So the measure of arc XY is 90 degrees because it's the same as central angle XPY. And then the radius of our circle is PX, which is 5. So now we have everything we need to find the length. So we just need our calculator. And you can do it in one step in a graphing calculator, or you got to do it in a series of steps in just a basic scientific calculator. But you don't have to have a fancy calculator to get this done, folks. That's not an excuse. So the first thing I would do is put 90 divided by 360 in parentheses. You can use the fraction template or use the division sign. Either one is fine. And then I would put 2 pi and 5 in another parentheses. And you don't have to put 2 times pi times 5. The calculator is smart enough to recognize that putting them side by side means to multiply, but if you're using a scientific calculator, yes, you're going to have to tell the calculator probably to multiply all that. All right, everything is good. Everything's in parentheses. All parentheses are closed. Hit enter, and we get approximately, it said round to the nearest tenth, so that's one place behind the decimal, ladies and gentlemen. I see an 8 behind the decimal, but behind that 8, I see a 5, which means the 8 becomes a 9. So it's 7.9 meters. Make sure you use your units. So about 7.9 meters for the length. So when you're talking about length of an arc, the units will be like meters, inches, centimeters, feet. But when you're talking about the measure of an arc, the units are degrees or radians. So make sure you know the difference. Come test day, so you'll get everything that you need correct. And please know how to round. Number 19 wants us to draw a circle O. Mm, stop it.